Hey guys, Steven here. So today I'm going to be teaching you how to create this wavetable. By the end of the video, you'll be able to create it and understand it. I'm going to give you all the theory. So let me go ahead and show you what it sounds like. It's a lot of fun. This one's, it's a good basic intro. So let's see. Really cool. I could do that for hours. Okay, so let's start. And before we start, let me just explain. So you've seen the two windows. You've seen this bottom window, and then you've seen this top window right here. This is called the frequency domain because you have frequencies, like here. You have a height. These are really high these are not high these are frequencies, but they're louder in volume the higher they are. And so in the time domain is not necessarily the case. If you have a high time domain, doesn't necessarily create a high frequency. The volume of each frequency isn't necessarily affected. So at some date, I'll explain what the relationship is between the two, but for now, you don't really have to know that. So all you have to know is that X is the time domain, and inputting into the frequency domain, you're going to be putting in Q, and that inserts partials into here. Okay. So let's go over to, I'm going to build it up step by step to get to the wavetable that I showed you. Okay. So you remember from, I think from the last video, I explained what X was. So in this video, I'm going to build on that concept and introduce some new things. So the first one that I'm going to show you is absolute value of X, which looks like this. There's two bars around it. Another way of writing it is ABS, abs, and then with parentheses. I'll show you, we'll go to serum in a second, and I'll show you, because serum only does it that way. So what that does is it takes all the negative values and it brings them up to the positive values. So here we have -3. Right here we bring it up to +3. Okay, let's go over to serum and let's put in ABS abs of X. And so notice that when we had X, there were some negative values, but now we're going to bring them up. Absolute value brings those up into the positive axis. And what's cool is we now have a triangle wave. So that's really cool. You just made a triangle wave. And before, this is a saw wave. So that's cool. You know how to make two shapes now. Okay, let's go. Okay, so now we got that part. Now we're going to make we're going to take these two functions and we're going to combine them and make another function. I'll explain which one. We're going to do that by taking the top one and dividing it into the other one. X divided by absolute value of X. So let's look at and it looks totally different. It looks like, whoa, what happened? So we have 1 here, and we have -1 as we move into the negative values for X. Okay, so, how did we get that? Like, if X is 1, then we have 1 divided by 1 is 1. If X is 25, 25 divided by 25 is 1. So no matter what number we choose, we're always going to get 1. Now, if we go into the negative direction, here's where it gets interesting. And here's where the absolute value comes into play. Negative 1 divided by absolute value of negative 1, which is, in other words, the negative. So it's positive divided by negative, and that gives us a negative value. If we had negative 1 divided by positive 25, or negative 25 divided by positive 25, we would get negative 1. So if you're not sure, brush up on like negative divided by a negative or negative divided by a positive, get those straightened out. So if we just had x divided by x, negative 10 divided by negative 1 instead of it. So we would get this graph. We would get the 1 here like a straight line. But that's what's cool about the absolute value of x. When it's below the x, this is what you get. And another way of describing that is called the sign, S-I-G-N parentheses x. That's another way of describing it. Okay. Let me just do it here. So we're going to be using the sine of x, the other one. It's kind of a shorthand, so that's why we don't have to keep writing x over abs of x every time. So here we have the sine of x. Okay, let's go over to serum. Okay, we get this square wave right over here, just like we saw in the graph. We have sine of x. Now we can also do sine of q. Let's try that. And we get just like we did. But see, now here's the thing about the q, is that we're starting from 1, because there aren't any 0 frequencies. There's only 1 frequency, and we're starting at the 1, and it's all 1 for here to infinity. So that's what you're seeing here when you see the frequency domain. That's what you're seeing. Okay, so now this graph by itself is not, it's kind of nice, but what do we do with it? Like, what can we do? So we can move the graph really easy. It's kind of a easy technique. All we're doing here is, remember how we had x, and if I said x minus 5, do you see how if the graph moves down, so 0 minus 5 is negative 1, so all these values are moving down, and it looks like the graph has moved over. It effectively has moved over in the x direction as well. So that's why, by saying sine of x minus 5, we move this graph over to the 5th position. Or if we do sine of x minus 20, we would move over to the 20th position. So that's the technique to moving the graph. So we could either do the other direction. We could do sine of x plus 5. And that moves us over into the negative directions. So if I move the graph up, x plus 5, we would move the graph up, and effectively we would move it over. It would be like moving it over to the left. So when we do sine of x plus 5, we move the graph over to here. So let's do that in serum. So let's see, sine of q minus 40 moves the whole graph over. Now you're probably wondering why. Like, here it's 40. Why do we have 0 here instead of 1? Notice that get rid of these for a second. Notice that the sign of x, we have 0. At the 0 position, we have 1 and -1. So which one do we choose? So we have to take the average of both of those. We have to factor both of those in. And we end up with taking the average 1 minus 1 divided by the number of elements, I guess. The average, just taking the average of something, and we end up with 0. This middle at the point where these converge, where you have 1, -1, and 1, we have 0. So that's why in serum we don't have a value for 40. It only starts at 41. Okay, so cool. Okay, now we can also go to the time domain there. And we can move it over. Let's move it over. Well, we can't do 4 because watch what happens. If we do 4, we move over past the 1 point. The 1 point over here is it only goes up to 1. So we're gonna have to stick with numbers below 1. So in this case, 1/2 or 1/8 or 1/8. Let's see, 1/8. Like that, or you can do even decimals if you 0.23, and we'll move over from the origin. Here's the origin we're moving over, 0.23 places. Okay, cool. Okay, what we're gonna do now, we're almost getting to the punchline. We are going to take the sign of x, and now we're going to reverse the signal. We're going to reverse the signal, so we have this. Reverse the signal, and now we're going to move the signal over. I put the x in parentheses, and then I'm going to say like 5 places. Flipped it, and now we have negative frequencies. Those don't count because they're below. Think of this as the volume. We have a volume of -1. There's nothing there. It's below 0. So here we have the volume of 1, of a complete volume. And we're going to do, let's write this in serum now. So this is the cool part. This is where we're going to get sine of minus q minus 5, 4. Oh, cool. So we have our first frequencies. And here we have 15. Actually, let me clear that for a second. Now, q minus 12. Okay, here. So cool. So we can go 500 or 1,000 if we wanted to. 1,000. But serum stops at 512 partials, so we could, the max is, that's the max, so we can't go to 10,000. Let's go to 4. Okay. So now let's make a wave table. And let me briefly explain. I'm going to go back to my graph. So we could input all those numbers and just do that and say x minus 5, x minus 10, and do all that. But if, let's say we want now a scale of numbers. Let's say we want to make a wave table. We don't just want the numbers. We want more than just one frame. So serum, in order to do that, we need a slider. We're going to use Z as our slider. And let me open that. So when we start our slider, we're moving. But now we don't just want one number. We want to be able to go maybe 50. So what we do is we do 50 times z, meaning we're going to do 50 times that 1. What's 50 times 1? It's 50. Or 30 times 1 is 30. So wherever you want to go, put that number in. If you want to go 1,000, 1,000 times z. So let's go back to serum. Okay. Let's put a parentheses in there. Okay. Let's go to 50. 50 times z. Okay. And there we are. Awesome. So you made your first wavetable. Now, let's see. Let's go all the way out. Now, remember we don't have always 0 because of the sign. Remember the middle point, the origin point is always the average of the two values. So just remember that you're not going to have that last value. But it doesn't really matter in our case. It doesn't really make a difference. Alright guys, so that's your first wavetable. Pretty cool stuff. We're going to build on that next time, and we'll keep building on it. And have fun with that one. And I'll see you in the next